My colleague will be building the CubeSat as we speak. So.
Okay. Right, our next presentation is by the FUNcube-1 team. A hands-on demo is what it says. As you can see, we have the FUNcube being set up over in the corner at the moment. So I'd like to pass you over to Graham Sherville, G3VZV.
Thank you, Trevor. Good morning, everybody. Everybody here. Thank you for coming so relatively early on a Sunday morning after what was an enjoyable evening. And good morning to everybody who's watching on the stream. What we're going to do is just do a quick overview of what the FUNcube project was all about, a reminder, and then we'll move on to a demonstration which will be hands-on. We've got a couple of radios there communicating with the CubeSat, and we'll see how that goes, and we'll sort of morph that demonstration into the coffee break, which is the next item on your agenda, so then you can all come up and have a look and have a play and whatever, and then we can have coffee, etc. So that's the sort of plan. Anyway, the FUNcube project, just a very brief reminder, goes back actually 4 years. This idea came up as a KissCube project, keeping it simple. Then we realized we needed some money to build it. Then we found that we got a donation a donation to enable AMSAT-UK to build a CubeSat so long as it had an educational outreach mission. So that all went forward. In 2009, as it says here, we asked ourselves, could we create such a mission? Could it have an amateur transponder? Could we create a team of volunteers? I don't think you actually create, well, perhaps you do create a team, but could we get a team of volunteers together? Could we actually do the educational outreach, and could we fund it? Remember, that was 4 years ago. What we were planning then was that this whole project would be designed, built and flown in about a year or 18 months, which would have made it easier to keep the level of enthusiasm going. As it's turned out, it's now 4 years since the beginning, and we're still not yet in space. But we have a weekly Skype meeting, a weekly Skype chat every week of the team, and that's helped us over the years. Well, this sounds terrible. Over the years to keep the team together and properly motivate it. So the educational outreach, STEM subjects, latest acronym, science, technology, engineering and mathematics. From our side, covering radio and electronics and physics and looking at Doppler shifts and all this. We've also put on board a material science experiment looking at the loss of heat energy by radiation with different coloured strips. That's all there. Don't think we've got that on the EM though. And also fitter messages, which are like Twitter messages but longer. The telemetry is BPSK. The amateur radio operations, the spacecraft, the FUNcube-1, and we must be careful, there are two FUNcube missions now. FUNcube-1, which is a standalone 1U CubeSat, where you see the engineering model on the table there. FUNcube-2, which you heard mentioned yesterday by Steve, is a payload on UCube-1. Great potential for confusion there. Also, as it looked up to yesterday, it looked as though UCube was going to launch before FUNcube, so we could have had FUNcube-2 in orbit before FUNcube-1, but I'll come on to that. I think that may have resolved itself. So the FUNcube-1 is designed to operate autonomously between day and night. We concluded that most schools are working when it is daylight, when it's during the day. So if the satellite is in the sun, it will be in what we call educational mode or telemetry mode. So it will be transmitting high-power telemetry that schools can receive with relatively simple antennas and receivers. At night, when the satellite is in eclipse, it will autonomously switch over to an amateur transponder mode so that radio amateurs can use it when they get home from work. I appreciate that that's a terribly simplistic view of the world and how it works, but that's the baseline autonomous operation. And then we can, from the ground, command it to do different things during holiday periods or for special demonstration. We can keep it on telemetry permanently or for a certain number of hours. So the ground segment was also part of our project. We had to develop a ground segment. In the very early days, we were thinking of a simple sort of radio that would take an aerial and output audio that we'd run into a computer. And then Howard went away for a few months and came up with a hand-built thing that looks almost exactly as it does now. I've got number 5. I'm very proud of that. It's all hand-wired and amazing. But he's now sold, I've lost track, I guess it's 11 or 12,000 of these things. And they're continually, that's even before we've launched the satellite. And the point, of course, is that for every one he sells, he sends a large donation to AMSAT for our next project. Almost the FUNcube dongle has probably sold enough now for us to buy another launch. So it's fairly significant. That's a geek porn picture of the inside of the dongle Pro Plus. Okay, the FUNcube-1 hardware. The 3 boards that we as AMSAT-UK made were the command and control board, an RF board and a PA board. This is the command and control board, very low power. That was one of the main prerequisites. Obviously on any satellite the power budget is really important. On a 1U CubeSat, where you're trying to operate the transmitter all the time, then the power budget becomes not important. It becomes absolutely the most important thing. Well, that and thermal, I guess. So very low power consumption of the onboard computer. You'll see that there's a number of connectors on there. Obviously the main, it's loud, the main PC104 or CubeSat kit bus, I think it's called there. In terms of tradition, that's the most traditional part of a CubeSat. And then we've got connectors for, we're powering the ANTS, the antenna deployment system, which is a commercial off-the-shelf unit from ISIS, is powered and controlled on one of those connectors, and the other 2 connectors are going to these MSE strips, material science experiment strips, 2 of which are individual strips of titanium or aluminium, I'm not sure what we used in the end, but black and white strips, and 2 are actually thermistors glued onto the structure. You'll see a picture of the structure in a minute and I'll point that out. Said picture. Here we have the FUNcube-1 engineering model, which is actually what is over there on the table. It's now got some dummy panels on the outside. And here is the actual flight model before it was completed. And you can see that the structure is half black, which is the standard black anodizing for a CubeSat. And the other half is, well, it's silver anodized, but it's got some blue capped-on tape to protect the surface on it. So those are the 2 parts of the structure there. In terms of the RF and PA boards, the RF board is the most complicated of the 3 boards. It's got stuff on both sides and lots of components. I've not actually seen the declared materials list from the RF board engineer. We have a continual battle in our project to make sure we've got some documentation. Well, in fact, any documentation will do. But it's very clever. It works well. And the PA board here from David. I can't see David in the room anyway. He's hiding. And David's designed and produced this PA board, which amplifies a very low level of RF from the RF board and amplifies it up to about 250 milliwatts. 300 milliwatts is the number that we were actually measuring of the flight model for FUNcube-1. FUNcube-2, for no particular reasons, is actually transmitting a bit more power, taking a bit more current, but as they've got deployable solar panels, I'm sure they can accept that. That produces about 400 milliwatts. So those are the 3 boards. More porn, geek porn. Very beautiful photograph, I think, this. This shows the CCT board, the transponder, and the amplifier are all AMSAT. The power system is from a Danish company called GomSpace, so if anybody's watching from GomSpace, thank you for the power board. They worked very well. The structure is from ISIS, and the antenna deployment system is from ISIS. Also, the solar panels are bought through ISIS, and I understand the panels come from Germany. They're mounted in Israel. So the aluminium mounting that they're attached to is from Israel, and they're assembled in Italy. So it's a truly pan-European project. That's rather nice to say. FUNcube-1 telemetry, our BPSK has got forward error correction. We'll demonstrate that. You'll hear it in a few minutes. There's 24 frames. We've got real-time data every 5 seconds. Whole orbit data is sampled every 60 seconds and stored for 104 minutes, so you can actually look at what the temperatures were, what the battery voltages were, what the solar panel currents, I think, are spread back over a complete orbit plus a bit. And then high-res data at 1 second intervals, so that we can, so long as it's not tumbling too fast or spinning too fast, we'll be able to look at the solar panel data quickly enough to determine how it's tumbling and how it's rotating. We only have a passive attitude control system. Then, as I said, there's lots of fitter messages, and the point of it's just good luck that the sound is very distinctive. You'll hear it go every 5 seconds. It beeps at you. So if you're listening for a signal, you should be able to hear it quite easily. On the bottom left-hand corner there is a drawing showing the stack. Nothing particularly clever about that, other than we've put the battery. One of the things on a CubeSat or spacecraft, of course, is you've got to keep the battery warm, certainly above zero. So we put the battery next to our PA. The PA radiates in heat, probably a couple hundred milliwatts as well, so that's acting a bit like a battery heater. How well that will work, we'll find out. Frequencies, I get terribly confused with all the frequencies. This is a chart that shows all the frequencies that we're using at the moment. We've got FMs are the flight models, EMs are the engineering models, and with different crystals on board, we've got different mixtures. But the numbers on the left are going to be the interesting one for people to use, because they're the ones that are going into space. So you'll see that the transponder is only 20 kilohertz, but that if both appear together, hopefully there won't be too much overlap. There could be some overlap if one's coming towards you and one's going away, so you've got sort of 6 kilohertz of Doppler, but we've hopefully separated them just about far enough apart. Lovely, beautiful photograph of a lovely, beautiful spacecraft. That is the flight model of FUNcube-1 after it had its antenna deployment test. Antenna deployment test. Let's see if this works. I will keep talking while it goes away and loads this up. Talk amongst yourselves for a second, chaps. Did I? Oh yeah, thank you. We should have some audio on this, sound man, sir.
7, 6.
Okay, run for the audio.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, go.
Antennas are deploying, Jim.
I think we have a decollage.
Yes, sir. It works. Antennas are deploying, Jim.
I think we have a decollage.
Yes, sir. Antennas are deploying, Jim.
I think we have a decollage.
Yes, sir. Antennas are deploying, Jim.
I think we have a decollage.
Yes, sir. It works. And it has started in MCU. It just started.
And it started in the right mode, which is another. So thanks to Wouter for putting that video together, and thanks to Jim for his insane laughter. But that just showed the relief. I think it was just terribly relieved that, because obviously if the CubeSat, well, any satellite, if it doesn't deploy the antennas, then it's not going to be very much fun. I wasn't allowed to get involved with the integration of the CubeSat, FUNcube-1. I'm not qualified, but I was allowed to touch it once in the clean room. So for me, that's a significant picture. Go away, Michael, because that was as close as I got to it. But it was lovely. FUNcube-2, one of the pictures we were hoping to show you yesterday was a live webcam picture from the clean room up in Glasgow. For some reason, the log me in thing didn't work, but that was a picture I snapped about a week ago, I think, from the webcam. So you can see a 3U CubeSat sort of half assembled or put together and working quite well there. To receive the satellite, you need a receiver. It can be an 817 or something like that. It can be a dongle, FUNcube dongle, and we'll be distributing some software for doing the decoding and displaying of the telemetry. We call that a dashboard. This originated as the engineering model of the dashboard, and we were going to produce lots of educational dashboards as well. That hasn't yet happened. The educational dashboards working for, designed to be used in schools to display different things. We haven't got that far yet, but it's not very clear on that, but you can see the vast amount of telemetry that we're capable of receiving, lots of temperatures, lots of currents, lots of voltages. That's a rather clearer shot. That one's actually from FUNcube-2. No, it's not. That's another FUNcube-1 one. I'm wrong. But you can see the debug data and tuning, and it's all there. It's really good. This one is from FUNcube-2. You can tell which satellite you're receiving because down the bottom it will tell you satellite ID FUNcube-2 on UCube. You'll notice that some of the panels are slightly different because it's a 3U CubeSat with deployable antennas, sorry, deployable solar panels and everything. The software is picking up different telemetry channels. Interestingly, or hopefully interestingly, on FUNcube-2 on UCube, there are magnetometer readings that we'll be able to pick up the data from, so that will give us another opportunity to look at satellite attitudes. So what do we expect to see if you fire up SDR Sharp or something? This is an old FUNcube dongle, so you've got the big peak in the middle, and this is listening or looking at FUNcube-2, where you would have our signal here, so ours is going to look like that, and if UCube's sending its CW beacon, then it would probably look something like that. Don't forget that as well as the dashboard, the data that you receive, you'll be able to forward that data onto a central warehouse written by Dave over there. So he's set up a central warehouse on the internet so that we'll be able to store all the data that we get, and it will be possible for schools or colleges to then collect that data and assemble it and use it for their own analysis. Slightly out-of-date slide. This is showing the launch status as it was about 2 weeks ago. FUNcube-1, Dnepa launch from Yasny, still booked for November 2013. The Dnepa launches have been sort of on a standstill for a year or so, so it's been a bit sort of uncertain, but we now understand that at least 3 have been authorized for this year. 1 is scheduled to launch next month. I'm not sure quite when in August, mid-August, I think. And if that, our belief is, if that one goes ahead successfully, then we're certainly on the launch after that, which is slated for November. So please keep your eyes out for any reports of Dnepa launches. Probably, if you don't hear it, it's good. Hear about it, it's good news. It hasn't blown up. And so I'm as confident as I can be at this moment that the November date is possible. It's not yet fixed, but it's certainly possible. The FUNcube-2 on UCube, well, we thought it was going to be September. Somebody said it was going to be the 32nd of September. Then it became the 26th of October. Then, as you heard from Martin yesterday, a Proton dumped landed on the Soyuz launch site or near the Soyuz launch site. So all bets are off for the moment as to how much damage that's caused. But information about the Dnepa launcher, that's an SS-18 with a nice new name and a new paint job. And some of the... and some of the vibration levels that we had to get through the testing at RAL. RAL kindly provided us with access to their vibration table, and we shook the EM actually, and nothing fell off. So launch and early operations from Yasny. We believe that the launch, although we've not yet had any TLEs or whatever, we believe that this will be the sort of launch, the sort of orbit that we'll see. We will deploy our antennas at 26 minutes after launch, and 10 seconds after that it will boot up, Walter? I think it's 10 seconds after the antennas are deployed. The system will boot up, so 26 minutes and 10 seconds, hopefully we'll have some radio amateur receiving. That shows where we believe it's going to happen. So we will be looking for radio amateurs in the southern part of Africa to tell us that it's alive. The orbit there, when it then goes, it goes nicely over Antarctica. I don't know anybody in Antarctica. Mike may have some. Okay. And then up the middle of the Pacific, so presumably we're then waiting for somebody in Hawaii to shout. Yeah? And then Alaska. So there's it's flying over an awful lot of water, unfortunately, its first orbit. But I think we hear it in the UK on the first pass over Europe. Certainly there will be people in Europe. So we're not going to have to wait too long. How are we going to do the launch and early operations, LEOP? So we've made an agreement with the RSGB where, as you know, they've got this nice new hut. Doesn't look like a new hut. It's intended not to look like a new hut. It's intended to look like one of the old huts. But that's, if you haven't been to the National Radio Centre, the hut is there. There's some antennas, HF antennas there. And although you can't see it on this picture, on the top of that chimney are the standard sort of Carlos Evis pair of WIMOs, as we used to have on GB4 Fun. Oh, as we've got outside here, of course. So those antennas are up there pretty well in the clear. So we're expecting to have mission control based at Bletchley Park, which will be rather good. If you haven't seen the inside of Bletchley Park, so a couple of pictures. In terms of educational outreach, to be honest, we've tried a lot and not yet achieved very much. It's quite difficult talking to teachers whose life is full of syllabuses and tests and all the rest, and you haven't actually got a product to sell. You've got a potential product to sell. What we've been able to do, though, literally in the last couple of months, is work with a guy called Anu Oja, who's the director of the National Space Academy up in Leicester. He's previously done a number of training sessions for teachers and produced some videos of those training sessions. There is a real classic one of him constructing a comet or cooking a comet. So if anybody's watching on the stream, just nip off after this presentation, do a search for Anu Oja cooking a comet, where he gets stuff on a table in front of you, and a bucket and a bin liner, a black bin liner, and puts bits of earth and soil and whiskey and stuff and liquid nitrogen, I think. Anyway, and he sort of shakes it all up and it all becomes rock hard. Then he takes the black bin bag away, and then you've got this sort of lump that's sort of suppurating with gas and bits flying off, just like you'd think a comet is. It's a great video. So he's a real trainer, an inspiring trainer. So hopefully he's going to do something as good as that with FUNcube. He's agreed to come to Surrey on Thursday to make the video. So a lot of our educational outreach is going to hang on that. And then there's a training session that he's leading at ESA with 40 40 teachers from all over Europe next month, where Walter is kind of going to go and take the same engineering model and do a similar demonstration. So hopefully from that the result will be a video available on the internet, an ESA-sponsored video on the internet with some background material for teachers. So that should be a good start. Right, I think, oh, that's just a picture of that. I think we've reached the hands-on demo stage. So Walter, come and do your hands-on demo. We probably need the trailing mic so we can hear him thinking. Will you need both hands to?
I think first get the radio.
Yes. Let's just listen to the telemetry stuff. So that's the telemetry that you can hear. Let's say every 5 seconds it beeps at you. Now what would you like me to do? Now what would you like me to do?
Let's see if you push
Yeah, yes.
Is it
Both
FM or
LLB.
Okay, so they should work then.
This is G3 exactly.
Yeah.
Yeah, G3
George 3 Victor, Zulu, VZV, testing FUNcube-1 engineering model. Okay, this is maybe not very impressive, but
if I show the camera, can you get the frequency on the screen, Peter? Okay, and then if Bouncer comes and does the same on his, you'll see that I'm talking on 77s and it's coming out on 2 meters with lots of feedback. Yeah, and this is G3 VZV on 70. Talking about FUNcube-1, which is on the desk behind me. Yep. So what? That worked. That's very good. So what we'll do during the coffee break is to set it up so you can see some of the telemetry as well. But at this point, I think we've completed the hands-on demo and a quick update on the FUNcube project. So thank you very much for listening.
What triggers the aerial deployment?
What triggers the aerial deployment?
I was thinking you would command it, and then I've answered my own question. Of course, if you can't till the aerials are deployed.
Yes,
so
the aerial deployment has to be autonomous because if the aerials aren't deployed, it's going to be a bit deaf. Yeah, the aerial deployment. What triggers the aerial deployment? It has to be autonomous because you can't command it from the ground because your aerials haven't been deployed. Yes.
Okay, Jim Heck.
Jim to answer. He knows precisely. He has documented it.
The reason that I was so chuffed during the video was because it is quite a long sequence of events and everything has to work. And as Graham said, if you don't get the antennas deployed, it's difficult. We can, of course, there is a command to deploy them, but before you get the command into satellite, you've got to get the satellite booted up. And what happens, the sequence of events goes something like it's popped out of the pod with its other 2 neighbours, and you would have noticed on the photos, you might have done there, 2 little micro switches which are released, and that starts the whole thing up. And the first thing it does, and Wood will correct me if I'm wrong, it boots up the processor on board, and the first thing the processor board does, it reads a few bytes in its memory, and it says, oh, this is the first time in space, as opposed to being on the ground when we don't want it to deploy the antennas. And then it sort of waits for 10 minutes. And the idea of the 10-minute wait is to say, to get clear of the other neighbours, the other satellites in the pod. And then it waits, I think, 10 seconds, because it does that every time it boots up anyway. Then it says, oh, have I deployed my antennas so far, or is this just another reboot because I've been in eclipse or something? And it says, no, I haven't, so that's another few bytes it's got to read. And then it says, right, I'm going to deploy them. And as you saw on the video, it does them one at a time. Does that answer your question?
yes,
Sorry, it's a bit long, but it is quite a long process.
yes.
Thank you, Jim.
Thank you.
You went through it. One from the internet.
Internet, yes.
From M0TFO, what has been the most challenging part of the project so far, bar the educational outreach?
Managing volunteers is like herding cats.
Yeah.
No, I mean, there's a number. There's not one outstanding one. It's gone on too long, not our fault. Being located in diverse parts of the world, or at least in 3 or 4 different areas of Europe, has been another challenge, getting people together often enough to get decisions made at technical level. And then remembering 6 months on why we made that decision, and that's still going on. And then the documentation, keeping track of everything. I think those are the 3 or 4 most important ones.
Right, any others? Okay. Thanks very much indeed, Graham.